Okay, good morning, everyone. Okay, a happy CNY for those who are celebrating. Alright, so for today's HBL, okay, I'm going to go through the reactivity series notes from page 1 to 10. Okay, so but before that, let's update our content page for the assignments in the first unit periodic table. All right, okay, for today's set of notes, okay, you can update it as such: reactivity series. Okay, today's date is the 31st of Jan 25. That's your notes. All right, okay. Right, okay, so write in your name, class, as well as today's date. Right, then we can get started. Okay, alright. Okay, so for the very first part is a recap, okay, on metallic bonding that we have learned last year. Okay, plus alloys. Okay, I think should be nothing very new. Okay, so just a recap on how metallic bonding looks like. Okay, so the delocalized electrons actually moves in one direction. All right. Okay, so let's say for example you have a circuit. Okay, actually I should draw it the other way around. Say you connect a piece of wire. So the electrons will go this way from left to right. Alright, so that's on metallic bonding, and then we'll talk a bit about alloys. Alright, okay, so basically the metallic structure is described as a lattice, okay, or positive ions in a sea of delocalized electrons. Okay, and then there's strong electrostatic forces of attraction between the positive ions and the sea of delocalized electrons. Okay, so for the color wise, appearance means the color. Okay, most of the metals are shiny gray except for copper and gold. Okay, copper of course is reddish brown, and gold is shiny yellow. All right, okay. Then last year we also talk about the high melting and boiling point for metals. Okay, so again that four things that you got to talk about every time we discuss melting and boiling point: energy, type of forces of attraction, okay, as well as the particles. Okay, so the particles in this case is your cations and the sea of delocalized electrons, as well as the structure. All right, okay, I'm going to highlight in them in four different colors. So this case, large amount of energy required to overcome strong electrostatic forces of attraction. For the particles is positive ions and a sea of delocalized electrons, and then lastly the structure is a giant metallic lattice structure. All right, okay, so moving on. Okay, we explain, okay, how come metals are very good conductors of electricity, because of the presence of the sea, okay, of or mobile delocalized electrons that allow them to act as mobile charge carriers to conduct electricity. Okay, so basically you're going to mention the type of mobile charge carriers. Okay, so this case is the mobile delocalized electrons. Okay, for the ionic bonding, there is a cations. I mean the oppositely charged ions carriers. So you got two types. All right. Okay, then for pure metals, okay, why they are ductile and malleable? Okay, so small typo. Okay, regular. Okay, so in pure metals, okay, the atoms are in a regular arrangement, which allows the layers to slide over one another easily when a force is applied. So that's why they are ductile and malleable. Okay, of course, malleable means you can bend easily without breaking. That's for pure metal. Okay, so this chapter will be discussing a lot about the reactions of metals. Alright, okay. And then another thing is that it can be stretched. Okay, that means can be put into wires easily. Alright, okay. For the alloys part, okay, they are harder and stronger. Okay, I need to change one thing. Okay, the phrasing down here. Okay, okay. I would like to change this part. Alright. Okay. So how to explain why alloys are harder and stronger? So I got 3 points to explain. Okay, point number 1. Okay, firstly, because let's say for example you look at bronze, the added atoms. Okay, so I say your tin, the added atoms. Okay, must change this one. Okay, important. Okay, because sometimes when I ask you about alloy, you got to be explained in this way. Okay, the way in your notes not quite correct. I need to change it a little bit. Alright. The added atoms are of a different size. Okay, so this second thing, this disrupts the orderly arrangement okay of depending the main metal. Okay, let's say in bronze is copper lah. Okay, then number 3, not enough space right here. When a force is applied, okay, the layers of insert the main metal okay, cannot slide over each other easily. Alright, so please note down the chain phrasing over here. Alright, okay, so some common alloys okay that your study include steel, which is for iron and carbon, stainless steel, iron, chromium, nickel, carbon, brass, copper, and zinc. Of course, there's always a majority lah. For steel is iron, for stainless steel also iron, for brass and bronze is copper. Alright, okay. So we are going to look at some questions discussing the percentage of the metals. Right, in your assignment 9A. That's the assignment that you do after this HBL lesson. Alright, there are some interesting questions for you to look at from past year O level. So do attempt them. Okay, they are very, very good questions that gives you very, very good exposure, I should say. Alright. Okay, so we're going to look at this reactivity series. Alright, okay. Right, okay, so there's a way to remember them. So sometimes people insert some reference point, such as hydrogen, as well as carbon, okay, on this reactivity series. Okay, they are not metals, okay, but merely some reference point. Okay, so in order to so-called remember, okay, this reactivity series okay, there's some acronyms that can help you okay, like potassium is the first member. This one is the most reactive. Least reactive is silver. Okay, so you can this one please, potassium stop calling me cute zebra. Iron I like having called maybe Simon. Alright, okay, just an acronym to help you remember. Please stop calling me cute zebra. I like having called Simon. Alright, okay. So basically, the difference in reactivity, okay, actually there's a meaning. We don't just say like potassium is more reactive because it's more reactive. Okay, there's a reason why you say so. So usually the more reactive one is because they have a higher tendency, okay, to lose electrons. That's why we say more reactive. Okay, that means higher tendency to be oxidized. Okay, then the least reactive one, okay, is I should say higher tendency, okay, lower tendency lah. Okay, lower tendency, okay, to lose electrons, higher tendency to gain electrons. Okay, so lower tendency to be oxidized, higher tendency to be reduced when it's an ion. See, to be reduced as a ion. Okay, so this part is important. Okay, I want to stress this part because later on when we talk about how to discuss, okay, metal displacement reaction, sometimes you need to elaborate a little bit in terms of the electrons. Alright, okay, higher tendency to be oxidized or lower tendency to lose electrons or higher tendency to be reduced as an ion for the less reactive one. Okay, alright, okay, so please note down this part, very very important. Alright, okay, next one. Okay, the first reaction that we're going to talk about with cold water. Okay, I don't think it's something very 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 new lah, I should say. Alright, okay, so some metals, okay, reacts with cold water to form metal hydroxide and hydrogen. Okay, which actually we got covered already. Okay, soluble metal hydroxide are alkaline, right? Soluble, okay, metal hydroxides, we call it alkaline. Okay, we should cover in the previous chapter of periodic table. Alright, okay, so we call that MWAH, right, earlier on. Okay, but this case is hydroxide, okay, soluble ones. Most of the time is soluble except for the magnesium case. So this applies for the top four metals. Alright, top four metals. Okay, so for potassium one you already seen lah. Okay, earlier on in group 1. Okay, so all these are the alkaline metals fellas. We should learn before we. Okay, so there's a little bit of like recap over here. Okay, so explosive lilac flames dart around surface of water and then effervescence of colorless and odorless gas. Okay, so basically all gives you the metal hydroxide. Okay, so sodium one, same thing, sodium metal float on water, effervescence of colorless and odorless gas. Then you have an orange flame. Okay, so by the time go to calcium, still quite fast, but not to the extent of explosive lah. Alright, okay, then magnesium. So basically this one top 4 metals means the group 1 and 2 metals, if you realize. Okay, so of course I hope you still remember how to write chemical equation properly lah. Okay, if you don't know, please go and recap. Okay, so the potassium and sodium case is 1:1. Okay, this one you it's not 1:1. So different charge. You will need to crisscross with brackets. Okay, crisscross with brackets because OH minus is a polyatomic ion. Likewise for the Mg2 plus case. Right. Okay, then beyond that, zinc to silver, there's no reaction. Okay, alright, okay, then the next reaction that we are going to talk about is the reaction with your steam. Alright, okay, so this one applies to your top 6 metals. Okay, so later on, okay, we'll take a look at some videos. Okay, hopefully it doesn't affect my recording because sometimes I play video, the whole sound is gone. Alright, okay, so maybe when you come back then I play the video. I think it's better. Alright, okay, So metal plus steam gives you metal oxide and hydrogen. I like to call this reaction the MSMH. Alright. Okay, so you can see it's collected using this gas collection method, downward displacement of water. Okay, largely because hydrogen gas is insoluble in water. Okay, so yep. Okay, so this reaction applies to those top 6 metal from potassium all the way to iron. Alright, okay, so for the magnesium case, okay, you'll see a bright white glow and then a white solid. Okay, this white solid is actually your magnesium oxide. So magnesium plus steam gives you magnesium oxide and hydrogen. So of course, hope you still remember how to write the chemical formulas for magnesium oxide. Is a 1-to-1 case. This one, remember, there's no charge. Please don't go and put 2 plus down there. Alright. Okay, likewise for steam. Steam is Zn2 plus O2 minus. But something very characteristic about zinc oxide is that it's yellow when it's formed, when it's hot, and then white on cooling. Yeah. Okay, then balancing an equation. The iron one is a bit special. Okay, this one actually no need to know Very, very special. It's like a mixture of iron 2 oxide plus iron 3 oxide together. Very, very unique. Okay, so from lead all the way to silver, there's no reaction. Alright, okay. So that's for the metal and steam. Gives you metal oxide. Just now was metal and cold water. Gives you metal hydroxide. Okay, so please take note the difference. Okay, the next one I think you should be super familiar. Okay, this one is top 7 metals. Because last year you learned metal with acid gives you salt. This is a salt and hydrogen. Okay, so I like to call it mesh, right? Last year when we learned it. So it applies all the way from potassium all the way to lead. Okay, lead is special because it forms your insoluble lead 2 chloride. So last year you learned about the solubility of salts, right? Okay, so basically all the halide salts, they are soluble except your lead and silver LS halides. Okay, so basically lead 2 chloride is insoluble. Likewise for sulfate okay, sulfuric acid, lead 2 sulfate also insoluble. Okay, so what happens is that okay, let's say you put a layer of lead metal okay, after a short while you get this lead 2 chloride okay, this one is your hydrochloric acid okay, so the produces insoluble layer of lead 2 chloride that prevents further reaction with acid. Okay, so there's an insoluble layer preventing the metal from reacting with the acid. Further reaction with acid. Of course, all these reactions are actually redox okay, if you take a look at them let's say for this one, oxidation state from 0 to +1. Do you realize that they get oxidized? Then the hydrogen is reduced. Okay, earlier on also the same thing. Alright, okay, let's see, we take a look at this from 0 to +2. Okay, so the metal is oxidized lose electrons, oxidation state go up. Hydrogen from +1 until 0 okay, so the hydrogen gains electrons are reduced. Okay, likewise when you go to the metal case, this is from 0 all the way to +1. So this is oxidized and this from +1 to 0 okay, so this part is reduced, right? Can alright, okay, so as a sum up okay of the first three reactions that you learn. Okay, so you have metal and water gives you metal hydroxide and hydrogen. This one is metal and steam, which is also water but in the gas state. Forms metal oxide and hydrogen, and then you have metal and metal and acid. Okay, gives you salt and hydrogen. So this is top 4, this is top 6, this is top 7, 4, 6, 7. Okay, magical number. Okay, so use this chance, okay, to work on, okay, the equations. Okay, I'm gonna take this out. Okay, when we come back, I'll go through with you, except for the last one. The last one is a bit unique. Okay, maybe this one I show you is a combustion of metal. The last one. Okay, combustion of metal. The rest I'll let you go and try it out. Combustion of metal gives the metal oxide. Okay, so slowly you look at which reaction is this. For example, like the first one is metal and water. So it gives you metal hydroxide plus hydrogen. Okay, metal hydroxide plus hydrogen. Okay, the next one is metal and steam. Okay, it gives you metal oxide plus hydrogen. Okay, so all of it somehow produce hydrogen. Then metal plus acid. Okay, this case can, because you produce the lead-2 nitrate. Okay, which is soluble. That's why this reaction can proceed. Okay, alright, so you go and do up. Okay, the next one I think is a quick example on looking at reactions with the various metals. So usually the tip here is if you are looking at acid, right, it will help you to see the least reactive one. So usually at the bottom, right, they won't react with the acid one. Like for example, this one is confirmed number 4. Okay, S is confirmed number 4 because no reaction with acid. Okay, then fast, extremely vigorous, very slow. Okay, so looking at this, V should be number 3 Okay, then water, usually you can see the most reactive metals because only the most reactive reacts with cold water. Okay, so this is vigorous, is number 1, this number 2. Alright, and where do you place hydrogen? You place it between one metal that reacts and one metal that does not react. Okay, which means is actually down here Between S and V, you put your hydrogen. Right, S don't react. Right, S don't react with acid. V actually reacts, although very slow. Okay, reacts slowly. Okay, then what happens when you put metal U, the number 1 metal inside? Okay, likely this will give you an alkaline. So it'll turn violet from green. Then you write down the equation. Okay, likely something like sodium or potassium. Can? Alright, okay. Alright. Okay, then we have this displacement reaction. Alright, okay. Again, I got a video to show, but I'm very afraid that once I show it, then the video got this recorded video will have no sound. Okay, every time I do that, somehow the video got no sound after that. Okay, I don't know why. Okay, so let's look at displacement reaction. Okay, it works a bit like halogen displacement. Okay, so the idea is more reactive metals can displace a less reactive one. So usually the more reactive one is the one with higher tendency to lose electrons. okay, or the one that has a higher tendency to be oxidized, okay. So the less reactive one from its aqueous sort, that means the one with a higher tendency to get, okay, to gain electron as an ion. Okay, that means to say get reduced lah. Alright. Okay, so from this they can ask you a lot of questions to ask to explain, write observation, write ionic equation, write chemical equation. Okay, down here, very important point. More reactive metal, higher tendency to lose electrons. That means higher tendency to be oxidized. I hope you haven't forget your redox. Okay, reactivity series, and this is very closely related to redox. Alright. Okay, so let's say for example you put iron filings into this blue copper 2 sulfate. Then you ask yourself, okay, this is like a musical chair. Is this more reactive? Okay, if yes, then you will displace the copper 2 ions. Okay, copper from copper 2 sulfate, right? Okay, so take for example this case, all right, okay, you can ask you for observation, explanation, or this. Okay, so one thing they can ask you is observation, okay, so you will see a pinkish brown or reddish brown solid deposit, then a change in color of solution. Okay, so there's always not always lah, okay, but the solid deposit always will happen. Okay, but color change in solution depends, because sometimes, let's say for example you are using magnesium and a zinc solution, probably you won't see any color change in solution because both are colorless. Right? Okay, then okay, so the key thing is to really focus on the metal and the metal cation in the solution, not the anion in this case. Okay, so explanation is the second thing they can ask you. Okay, so again, same thing. First thing, you compare reactivity, and second thing, say the effect. Okay, so depending is a 1 mark or 2 mark, okay, you might want to, if it's 2 mark, you might want to add on this point to say that which metal, okay, has a higher tendency, okay, to lose electrons. Okay, if it's 2 marks, right? Okay, so I compare reactivity, which is this part. Then I say the effect, okay, what will displace what from its solution. And then the third point, okay, which metal has a higher tendency to form electrons, okay? Or you can say lose electrons, okay, or you can say oxidize, okay? Then the third thing they can ask you is of course chemical equation or ionic equation. Alright, so this is of course, you know, the very standard things, okay, but of course if you have to take copper plus iron 2 sulfate, then no reaction will happen, okay, no reaction, largely because this one is less reactive, right? Copper is less reactive. Alright, so again you compare reactivity for the explanation. Okay, again compare reactivity, because copper less reactive, so the effect is cannot displace, right, iron from iron 2 sulfate, because copper metal has a lower tendency to form positive ions. Okay, then similarly okay, the reactive metals can reduce or displace less reactive oxides. Okay, so the explanation is the same thing. Okay, in this case, your zinc and copper 2 oxide. Alright. Okay, so zinc is more reactive, then can displace copper to form zinc oxide. Okay, so basically you just do a swap in terms of the naming over here. Alright. Okay. Yeah. Then because zinc has a higher tendency to form positive ion, or rather higher tendency to lose electrons. Okay, or get oxidized. Different ways to say the same thing, but you must be able to do it in a different way. Right. Okay, then this is an example. You can go and try and write out the chemical equation. Okay, this one I don't want to spoon feed you. You go and try. Okay, so magnesium with should displace zinc and copper 2 nitrate. Then the observations that comes with it. This case, if you realize there's no change in the color of the solution. Alright, okay, because zinc and magnesium both, have colorless solution. That's why. Okay, then copper will not displace anyone. Okay, so still back to redox. Metal displacement is actually a redox. So basically, the more reactive metals is oxidized and the less reactive metals is reduced. Okay, largely because it has a higher tendency to lose electrons. Okay. Okay. Alright, so take for example magnesium and iron 2 sulfate. Okay, so this one is like a green solution. I hope you know iron 2 is green solution. This is colorless. Then you also see a shiny gray deposit on the magnesium metal. Okay, yeah. Alright, okay, then you can explain it in terms of the redox. Okay, I hope you still remember the format. Okay, whichever reactant is oxidized or reduced to whichever product, very important, as oxidation state. You never follow this format, usually I'll penalize you and you're going to lose a lot of marks. Okay, it's the symbol of element. So all these you can use the chemical formulas to write one. As oxidation state, then you put in the symbol of the element, increases or decreases from whichever oxidation state in whichever reactant to whichever oxidation state in whichever product. Okay, so the key things are here. Reactant oxidized to which product. Okay, because if you look at the oxidation state, this is 0, this is +2. So here is oxidized. The one displacing always gets oxidized. The one being displaced is always reduced. Okay, from +2 to 0, if you realize. Alright. Okay, oxidation state of Mg increases from 0 in Mg to +2 in Mg and so forth. Then the reduced side FeSO4, actually to be specific you should write the Fe in Fe. Okay, and in this part the Fe in FeSO4 is reduced to Fe wait as oxidation state of Fe decreases from +2 in FeSO4 to 0 in Fe. Alright, or otherwise electron definition also can. Okay, because your Mg loses 2 electrons to form Mg2 plus. Okay, so this case is minus 2 electron. This case is add 2 electron. Fe2 plus against 2 electrons. Right, okay. Then you can try out the examples. Okay, maybe I'll go through this one with you all. Okay, so an experiment was conducted to investigate the reactivity of 4 metals. The setup is as shown. Okay, so in beaker 1, you should know whether there's displacement. So you compare this one. This one is more reactive, right? The iron. Okay, then your copper is less reactive. So technically should displace This one displacement will happen. Okay, then metal X plus iron 2 sulfate. You see a shiny gray deposit, okay, around metal X. So this thing has happened. So yes, so X more reactive than iron. Okay, green solution decolorized. So got displacement. The other one, no displacement. So this one is actually should be less reactive. So X, the one inside the solution, is more reactive than zinc. Okay, so X is number 1, then zinc, then iron, then copper . Okay, so what happens in beaker 1 is that blue solution turns green, because what happens in beaker 1 is iron plus copper 2 sulfate. Okay, then we'll displace of course, iron more reactive. That was the example just now. So you get iron 2 sulfate plus copper, right? Okay, so this is blue, this is green solution. That's why blue solution turns green. Then this is reddish brown solid. Okay, then explain why is it a redox. Follow the format. Okay, try it out. This one you can add in the Cu in CuSO4. Right, important. Please go and add in this one. Okay, this one make sure you follow format. Above. Very important, because you all don't like to use this format. Always very, very important. Alright, okay. I don't know how to say how important, but it's really, really very important. Okay, please go and learn this format very well. Okay, very important. Okay, very important. As well as how, of course, how to calculate oxidation state which is covered in redox itself. Okay, then we go into all these metal displacement Okay, so you can go and write the equation. Okay, I don't really want to split, except like this case. Okay, this one is less reactive, so no displacement, you just put as less reactive. Okay, those who got displacement one, you go and write. I'll let you go and try it out. Alright, can. Okay, so make sure you fill out until page 10. Then for your homework, okay, it's actually assignment 9A. That is your worksheet 5, if I'm not wrong. Okay, then update your content page as well. Okay, this one. Okay, write your name, then the due date. Make it next Wednesday when I see you. That is 5th of Feb 25. Okay, but you can put it down as today's date . Okay, 05 assignment 9A, largely on alloys and the reactions that we covered today. 31st Jan. Okay, then write down the assignment. Right, okay. then I think that's it. Okay, so this is your assignment. Try it out. There's some very interesting questions that you can look at. Alright, like this one. Okay, very interesting questions that you can look at. Question 14, 15. Okay, and then this one also. Wow, this one's super interesting. Go and take a look at it. This one I give you a bit of hint. Yeah, suppose number of atoms is related to the mole. Okay, you multiply by Avogadro's constant equals to the number of atoms. So you need to find the number of mole. Okay, something related to like how you do empirical formula. Okay, you go and revisit a little bit. Okay, what you learned last year in mole. Can? Right. Then I think that's about it lah. So make sure you fill out until page 10. Alright. Okay, then this is it from me.